Thank you. Great to see you. Great. Thank you for coming. We spoke a bit earlier about the use of AI in science, the use in research, and specifically medical research. And that is something that you have worked on in the past. And so I'm curious to hear about how that went, where it's gone now that you work for NVIDIA. We spoke a bit about data sets, unreliable data sets, working with AI to improve data sets. So I'm curious to hear your perspective. Thank you.
Thank you for having me. And as you said, yes, I used to work in medical domain, but I no longer work in medical. I do collaborate with some colleagues on medical use cases, but I mostly work on tasks like perception, video analytics, robotics. So that will be also the main topic of my today's talk. And I guess, shall I start sharing? Am I good to go?
Yes.
Perfect.
Yes, go ahead. Go ahead.
Let me know if you can see my slides. Yes, I can see. So, all right. So the topic of my today's talk is addressing data challenges in perception AI by means of simulation. And the main motivation of this talk is basically that, well, in modern world, AI have many needs. And the first need is data. You cannot train powerful AI networks without lots of data. The second AI need is training, and by training we understand training infrastructure, AI models, AI architectures, and finally you also need to be able to test your models. You need to make sure that your AI models generalize well on all kinds of scenarios and in different environments. So in this short talk, I will focus on data explicitly. And well, in the past, those of you who have been working with data for some time, with, well, AI for some time, you know that real data is mostly used to train artificial intelligence neural networks. And real data, unfortunately, comes with lots of challenges. And those of you who've ever worked with images and image segmentation, you know that labeling is a hard and very tedious task. So you can have small objects, you can have overlapping objects, you can have just lots of objects, and your hands might be shaking. So it's really, really hard, for example, if you want to segment your scene for segmentation tasks. And when talking about LiDAR and radar point clouds, it's even impossible to do this on this data structure. So there are many, many, many challenges associated with real data. Not even mentioning that collecting real data also costs a lot of effort in terms of time and money. Here in this slide, I'm showing you some examples of our data set, which we use to train our autonomous vehicles. And yes, at NVIDIA, we work in many different domains, and autonomous driving is one of them. So here you can see that we can have data which is blurry or hazy. It will be really hard to label those. You can have some occluded objects. Some scenes can be regular, meaning that you, well, as an expert or non-expert labeler, you can even don't understand like what's going on. What shall I label here? Or some scenes can be very crowded, like you can have a big number of objects, and can be also very, very tedious to label these scenes. And in many, many different scenarios, it's actually quite modern practice to use synthetic data to tackle these challenges. So let's see what kind of benefits synthetic data has. But first of all, what do we actually understand as synthetic data? And the definition I found here is that synthetic data is annotated information that computer simulations or algorithms generate as an alternative to real-world data. And in short, if you reformulate this, basically that synthetic data is fake data. So in contrast to the data you collect from real world, synthetic data does not exist in reality. And as you can see here, like in this screenshot I'm showing to you, basically it's a digital twin of a factory, and we have reconstructed it in our Omniverse platform, and it comes with already automatically generated labels like normal maps, bounding boxes, segmentation masks. So by using simulation tools and techniques, you can achieve you can achieve something like that and create artificial data sets. And what kind of benefits can we have with synthetic data? So first of all, with synthetic data, we can address the ground truths which humans cannot label, like think of occlusions, some adverse weather conditions, and also there are some indirect features like velocity, speed, direction of movement, and depth. You can address those all with synthetic data. Synthetic data is also programmable. Think of the situations when your data set is biased towards some certain class. Like, for example, those of you who worked on detection, you may know Kitty data set, and you also may know that it's kind of biased. It's known for its lack of cyclists. And with synthetic data, you could easily address this problem by setting, okay, I want more cyclists in my data set, and you can get it by simply editing the code. Synthetic data is also, well, it allows you faster iterations in development. You can start development like from day one. You don't need to go in the field and collect all this data. It's also less cost, so you can save costs on collecting data. You can also save costs on labeling data. And synthetic data is also more accurate. So think of situations where, well, human observers, human labelers, they make mistakes. And especially you have no control on that if you use services like Mechanical Turk, where some people who, well, they just want to get money for that and can do their job quickly. There's no control on the quality of the segmentation, segmentation or bounding boxes or whatsoever. In synthetic data, you don't have this problem. Synthetic data is always perfect. Also, synthetic data can be used to address corner cases or the so-called long tail anomalies. So think of situations when you have like rare events which rarely happen in the real life, but still possible. So you don't want to wait until the next event happens just to collect this data. With synthetic data, you can just simulate this event. So this is very useful. And last but not least, synthetic data can also help to avoid data restrictions. So especially in Germany, all you know that we have GDPR, and sometimes it's a requirement to anonymize your data sets. Like if you have humans in data sets, you want to remove their faces or any features by which the humans can be identified. If we are talking about some open source data sets, sometimes they also come with some legal restrictions. So for example, you can say, okay, I published this data set, you can use it, but you cannot use your models, which you trained on this data set for, let's say, some commercial applications. And with synthetic data, if you have your proprietary data set, you're free of these obligations. So how deep learning with synthetic data works? But first of all, let's see how a typical deep learning training process works with real data. So you start with collecting real data, and then you label the data. Let's say in this example, we are obviously detecting cats. And then you're training your neural network, then you're evaluating your neural network. And based on the evaluation of your neural network, you see, oh, is it performing good? Do I need more data? Do I want to adjust my hyperparameters? With synthetic data, it's similar, but also a little bit different. So with synthetic data, you basically have the so-called generation of data. And I'm showing it, for example, here where you have the so-called contextual synthesizer, domain randomizers, and finally renderer. And using these technologies and all the steps are kind of parameterized, you create a synthetic data set. The next step, once you have your synthetic data set, you train the model the same way as you train with convolutional neural networks or whatsoever, transformers, and then you also evaluate your model. And an interesting thing that to evaluate your data set, you can fix the parameters of your model, and use this as a feedback loop, use the evaluation data as a feedback loop in order to tweak your randomizer. So you kind of can have this automatic closed loop in order to improve your data sets. And of course, you don't need to go in the field and collect more data if you see that your model underperforming, but you can easily influence the generation of your model by closing this feedback loop. One important thing you need to be aware of when training with synthetic data is the so-called seam-to-real domain gap. And seam-to-real domain gap can be of two different kinds. The first one is the so-called pixel-level differences to the real sensor output. Think of it, well, anything you can find different between reality and your simulation. It could be different capabilities of your rendering system. It could be different textures used. It could be even, well, different materials also. And the second type of content gap is the so-called, the second type of seam-to-real domain gap is the so-called content gap. By content gap, we understand differences in diversity, context, and behavior to real data. Think of it as like in reality, you can have, well, like only vehicles like cars and bicycles on the road, but then you've simulated some trucks and motorcycles. So if you compare this, they are kind of similar, but also there is a content gap in your simulation and reality. One powerful technique to address the seam-to-real domain gap is the so-called domain randomization. And in domain randomization, you basically vary the, well, the visual characteristics of your scene by tweaking such characteristics like color, lighting, textures, materials. You can also modify the scale of the object. You can rotate your object, and you can also simulate different movement. Think of it as creation of many possible variants of one scene you want to use to train your deep learning neural network. And domain randomization can be of different kinds. So the first way is to use the so-called realistic or minimal domain randomization, where you basically create a digital twin of your existing scene, and then you try to modify different visual characteristics like textures, lighting. You can also modify camera positions. You can modify day. You can simulate day and night. So, as like for example, in this video, I'm showing you we have obviously a warehouse, and you can all say, okay, it looks like a real warehouse, and we are just modifying the placement of the objects in this warehouse. It can be also semi-realistic or moderate. So, for example, in this video in the middle, I'm showing you it's a video of a room, and you can clearly see like there is a table, there are walls, there are some objects, and but the textures we use, they are not realistic. So it looks like rather crazy, and you can think like, yeah, it's a room where a crazy person lives. And then finally, you can also have the so-called unrealistic or highly diverse domain randomization. And there you just take your object and you can like simulate all kinds of textures and all kinds of constellations of objects. And it might be also useful. So, and the reason why it is useful is that in this scenario, we encapsulate the real-world conditions by high diversity in synthetic data set. So we're kind of trying to create a solution space which is much larger than the reality, with the hope that in this larger solution space, we for sure encapsulate the reality. And you might wonder, which is actually the right way to do this? And the answer is, well, it depends. And it might be also different for different scenarios. And in my own experience, it always requires some trial and testing. So it's better to try empirically and see what works for your specific use case. And also another good thing, you remember I mentioned that AI needs testing. So you can actually use the realistic or minimal simulation in order to test your AI systems. Let's say you don't necessarily have access to all possible reality conditions, so you can still use your digital twin in order to test your perception systems as well. At NVIDIA, we have a solution in order to, well, to solve this problem, to solve this replication problem, and it's called Replicator, and it is based on our Omniverse platform. And those of you who have heard of Omniverse, well, you know that it's a very with NVIDIA invest a lot in this product, and we believe it's the right platform to build metaverses or virtual worlds. And on top of Omniverse, we have many different extensions, and one of these extensions is Replicator. So basically, Replicator encapsulates the technologies like USD, programmability, and domain randomizations in order to create photorealistic scenes like the one in this picture by bringing your virtual assets, 3D assets, into this virtual world, and then you can randomize, like I'm showing here, different placements of the objects, different camera positions. I'm not showing you different camera positions here, but it's also possible. Different light sources, number of light sources, and so on and so forth. And on top of that, you can also render the scene so that it looks photorealistically, and it relies on NVIDIA proprietary technology for rendering and path tracing. The great thing about it is also programmable, so you can write Python scripts in order to create these scenes automatically. Omniverse Replicator comes in two flavors. One is Isaac Replicator for robotics, and we also have Drive Replicator in order to train our self-driving cars. And I think that's it for my talk. Last but not least, I'd like to advertise our NVIDIA developer program, where you can learn more about our tools like Replicator and many other software tools by NVIDIA. But also, what's more important, you can get the support of the whole community and our engineers. With that, thank you so much, and I'll be happy to answer your questions.
Thank you very much. Thank you very much, Ekaterina. Thank you for sharing. Incredibly interesting topic. I didn't know anything about synthetic data. Do we have any questions from the audience? Well, so I do have one last question, I believe. Now, being new to the concept of synthetic data, one thing I wonder is what are additional risks? You know, we've spoken about all the advantages, which do seem fairly obvious, but what additional risks? Why are business leaders maybe still cautious, and is that justified at all?
So synthetic data also has some challenges, and the first challenge, which I've mentioned, is seam to real domain gap. You need to invest some time in order to bridge this seam to real domain gap. And in the beginning, like, you create really nice photorealistic data set, and then you train your model, but it doesn't work. And you need to invest more time in order to make your data set better and closer to reality. Or if you're using like unrealistic simulation, then you also need to solve this problem. You need to make sure, like, okay, what's wrong? What am I missing? The second challenge of synthetic data is, of course, like, you need to bring the assets to the 3D world, and collection and creation of assets is another challenge on its own. So either you pay 3D artists to manually create these assets, and then you also need variability of assets, because like different objects can look differently, and they should look differently in a virtual world. You can also rely on techniques like NERF or instant NGP, if you've heard of those, to basically reconstruct real objects and bring them into virtual worlds. But it's also a bit, well, it requires some engineering. So as such, like, it brings you many challenges, many benefits, but it also comes with challenges which you need to solve in order to use it in the most efficient way.
Right. Thank you very much. All right. Well, thank you very much for sharing. Thank you very much for your extensive answers. This has been fascinating to hear about. This concludes the last presentation of today's event. Thank you, all of you who came and listened, all of you who joined online. Thank you especially to Morantex for hosting us here, and to the entire team that made today's event possible. I hope you enjoyed the presentations. I hope you had a good time. Everything, as previously mentioned, will be found on YouTube after the event. And for everybody here, our guests in person, feel free to join everybody else for the networking event and, well, talk about your reflections of a glass of beer or wine. Thank you very much. Have a good day.